Okay, this is Unit 3, Day 1, Absolute Extrema and the Mean Value Theorem. So basically this unit, our goal is to use the derivative to try to do some function analysis. So let's talk about what an absolute max and absolute min is. So if you were given the graph, it'd be easy to figure out the absolute maximum and minimum, but our goal is to be able to figure out where an absolute minimum or an absolute maximum occurs without the graph. So visually, if you did have it, the absolute minimum is the lowest y value that occurs in a given interval, and the absolute max would be the highest y value in the given interval. So notice that we get relative max or mins whenever there is a change when the function goes from like decreasing to increasing or increasing to decreasing there. And we'll talk about those later in the unit. But for this lesson, we're just going to basically how to find the absolute extrema. So if it asks you for the extrema, that's asking for both the absolute max and min over a given interval. What you'll notice about these absolute max and min is that they're going to occur at what we call a critical value. So the critical value occurs where the derivative equals 0 or the derivative does not exist. So our goal today is to basically make sure that the function we are given is continuous over the interval, aka make sure that there is no x value that you're not allowed to plug in, something that would make the denominator 0, etc. If the function is not continuous, then we're not able to find the absolute extrema. So once we determine that it's continuous, then you're going to take the derivative and see where the derivative equals 0 or where the derivative does not exist. Those are called your critical values. Then what you're going to do is you're going to go back to the original and plug in the critical values as well as the endpoints and look for the highest and lowest values. That's how you're going to get them. All right, so let's take a look at this example here. Find the absolute extrema of g of x over the interval -3 to 3. So the first thing we want to do is determine its continuity. And I can conclude that this is continuous. That's just a polynomial. Notice that there's not going to be any vertical asymptotes or anything that would make me nervous. So that is continuous. So I'll just write continuous, question mark, and I'm going to say yes. Okay, so that thing is going to be continuous. And now what we're going to do is we're going to take the derivative and we're going to set it equal to 0. Okay, so the derivative, so g prime of x equals, this is going to be a simple power rule derivative. So this times this is 6 divided by 3 is going to be 2, but it's negative. So we get a -2 x squared minus 2x plus 12 as my derivative. Okay, so then we're going to have to set that derivative equal to 0. So if I have to set this equal to 0, I know I'm going to have to factor, so I'm going to pull out a -2 at the same time. So I'm going to say -2, that'll leave me with an x squared, a positive x, and this divided by that would be a -6. And I'm setting that equal to 0 because I know that a critical value occurs when the derivative equals 0. So once I get to there, I'm going to factor. And I need to multiply to a negative, so I know it's going to be x with a plus and x with a minus. And I want to be a +3 and a -2. Okay, so those are my factors. So that means that I can conclude that there are critical values at -3 and at x equals 2. So again, those are called my critical values. Okay? Once you have those critical values, you take those critical values and the interval, and you plug them back into the original g of x. So you're plugging them into here, and you're going to find which value is the largest and smallest. So it doesn't matter the order. So I usually try to do my endpoints first, because otherwise I'll forget. Okay, so you're going to do g -3, g of 3, and then we're going to do our critical values. Oh, notice that one of them was already there, so that worked out. And we have this. Okay, so now you're just going to take those, plug them into the original, and see what you get for your outputs. Okay, and I'll just show this on the first one for time's sake. All I'm doing is taking -3 and again just plugging it right into the original. Just be careful, watch your squareds. It's 12, -3, and I also have a -3 there. Okay, so for that, when I went in and plugged that in, I got a -30. And very similarly, when you take 3 and you plug it in, I got a +6. And when you take 2 and plug it in, I ended up with a bunch of fractions there. I got 35 over 3. Okay? So I just take those, plug those right into the original, and that's what I got. So now comes kind of the conclusion. How do I take this and turn it into an answer? So these are all outputs. They're y values. So my extrema is going to be the highest one numerically and the lowest one numerically. So I would conclude here that there is an absolute max. So the largest of those values is here, okay? So that's going to be my absolute maximum, is going to be, 35 thirds, but the absolute maximum is at the point 2, 35 thirds, okay? And then I have an absolute min at the point -3, -30. And that's it. So you've got your answer. Sometimes people will go back and just kind of indicate that these were the 2 that they were interested in. And just make sure you're answering the question whether they ask you where it occurs. So if they ask you where, that's a point, or an x value. And if they ask you what is the maximum or what is the absolute minimum, then they're just asking for the y value there. All right. So then we can go on to a calculator question. So in this calculator question, it's asking you again for the extrema. So this time it's a trig function, so you want to make sure that you know how to plug those into your calculator. So I grabbed a calculator. I don't know if it's going to show up really great. But when you turn your calculator on, I just typed it into, first I have to take that. Okay, so here we go. We can, even if you needed to look at it, you shouldn't need to, but there's what that graph looks like, and I can tell you it's continuous, okay? So there's no problems there. You should know that without looking at the graph, though, because cosine, you don't have to worry about any asymptotes or anything with a cosine curve. It just oscillates back and forth. So we could say, yes, that thing is continuous. Okay, so continuous, and we're going to say yes. And then we are going to take the derivative and set it equal to 0. So take the derivative, so f prime. So the derivative of cosine is negative sine, so it's going to be a negative 2 sine x, and the derivative of negative x is just -1. And my goal is to take the derivative and set it equal to 0. So if I take that derivative and I set it equal to 0, oops, I forgot my -1 in there. Okay, if I set that equal to 0, then I'm going to get -2 sine x equals 1, divide both sides by -2. And I get a -1/2. So this is where you're technically inversing. Most of you would just say, where on my unit circle is the y value equal to -1/2? So hopefully you know that that's going to be done in quadrant 3 and in quadrant 4, where the y value is negative. Okay? So that's 7 pi over 6 and 11 pi over 6. And again, this is a calculator question, so if you needed to use your calculator to figure that out, you could. Then these, again, you're in radian mode, so those would be in decimals. I actually meant for this to be a calculator question to kind of help you out. Once you go to plug in, you'll kind of see the numbers get a little nasty here. But then, so I did my first step, right? I checked for continuity. I took a derivative. I took the derivative, and I set it equal to 0, and I got some critical values. So these are still critical values. And now I take those critical values, so you plug your critical values and endpoints of the interval into the original, okay? So what I'm going to do is go back and evaluate f of 0, f of 2 pi, and I do see that that is not included there, but you actually do still plug it in to evaluate there. And then I'm still going to do 7 pi over 6 and f of 11 pi over 6. So this is the part that you may want to use your calculator for, because if you tried to do it without your calculator, you'll see. Watch what happens. So we'll do this first one without our calculator. So 2 times the cosine of 0 minus 0. Well, that's 2 cosine of 0 minus 0. Well, the cosine of 0 is 1. So you get 2 times 1, which is 2, minus 1. So for this one, oh, sorry, did I write that wrong? So this is cosine of 0 minus, yeah, sorry guys, the original is minus an x there, so this should have been a minus 0 there. So cosine of 0 is 1. 1 times 2 is 2. And then we're going to do 2 minus 0, okay, is going to be 2. So that one you're like, okay, I didn't need my calculator. When you go to plug in 2 pi, you get 2 times the cosine of 2 pi minus 2 pi. So cosine of 2 pi is, again, just a 1. So you get 2 minus 2 pi. So this equals 2 minus 2 pi. And that's where you may want to go ahead and evaluate that using the pi key on there to get an approximation. So with my calculator, I got that was negative 4.283. And again, I did that because I kind of have a feeling when I go to plug this in, I'm going to get something where I'm not sure what's going to be the max or min here. So we're going to do 2 times the cosine of 7 pi over 6, and then minus 7 pi over 6. So cosine of 7 pi over 6 is negative radical 3 over 2, but then I'm multiplying it by this 2. So you can kind of tell when I did that. I mean, you could just write it as a negative radical 3 minus 7 pi over 6. So this is why I made this one a calculator, because it's very hard for me to determine what's bigger, this thing or that, without it. So when I did that in my calculator, that gives me a negative 5.397. And similarly for the last one there, again, it's going to be 2 times the cosine of 11 pi over 6 minus 11 pi over 6. And with the help of my calculator, I got that one. Oh, that's really close because that's negative 4.028. So again, I had to use my calculator here because just by looking at this and this, it's very hard to tell which one is the maximum or minimum there. So I've got those as my answers, and I'm looking for the extrema. So I look for the largest one and the smallest one. Okay, so my maximum, that's going to be the biggest number. So there's my max. Okay, and the lowest one for this to the left on the number line is going to be here. So that's going to be my minimum. Okay, and then you can write that in a concluding statement if needed. Okay, and this next one I wanted to take a look at it because it was a calculator question. So we wanted to figure out about this, the rate of the gallons flowing in there. So we've got the rate given by this. Now notice that that is a function times another function. So when I go to take the derivative of that, I'm going to have to use product rule. But first, again, it's a sine curve, so yes, it's continuous. You take the derivative, and it's going to be first times derivative of the second plus the second times the derivative of the first. So then we take that derivative, and we want to set it equal to 0. So since this is a calculator question, to set this equal 0, I want you to take your calculator, go ahead and put this piece into your y1, and I like to put 0 into my y2. So you do that, you're going to hit the y equals screen on your calculator and then type those in. And then you hit this graph key, and your graph might come out not looking super beautiful. So what you can do there is a couple things. You can either hit zoom and then trig, or you can actually adjust the window using the given t values you were given there. So maybe you change it and you do zoom trig. Sometimes that helps kind of zoom you in. And I actually think that'll work for me. So I'll notice that between 0 and 3, it looks like I cross a couple times there. So to do those, you're going to hit second, the calculate key, and then you're going to do intersect. It's choice 5. So right there, you hit it 3 times, and it was pretty obviously that one was 0. Okay, so you can record that. But then you're going to have to hit second, calc, intersect again. What I'm really interested in is this other point. I don't know if you could see that, but like right between there. So you need to get your calculator a little close to it before you hit. So we've got that, and that gives us our other intersection of 2.289. So I'm going to record those down as my critical values. So you take those critical values and those endpoints, you plug them into the original. So when I took these and I plugged them into the original up here, I got these. And that shows you that the minimum was 0 and the maximum was 3.945. So that tells you that the rate was the greatest at time 2.2 and the least at time 0. That's it. Okay, the last thing that I wanted to talk about in this video was the mean value theorem. And so the mean value theorem basically says that if you have a graph that's continuous, so like this one here, that somewhere on that graph, if you draw, say, a secant line that touches it here, we'll say over this interval, it touches it twice between A and B. So you can use your pre-calculus formula, which is that average rate of change formula, and the mean value theorem says that somewhere on there, the derivative will equal that. AKA, we don't know where the C value is, like, if it's closer to A or closer to B, but somewhere in that interval, the derivative will be equal to the average rate of change. So when you get these problems, usually it'll say something like, according to the mean value theorem, or something like that, or, find the value of C guaranteed by the mean value theorem. Okay, the steps are going to be very similar. For most of these problems, what you're going to do is make sure that it's continuous. Usually the problem will say something that it's, continuous. And then you're going to take the derivative. And then you are also going to find the slope using that average rate of change. And then basically what the mean value theorem says is that step 2 and step 3 have to be equal to each other somewhere in that interval. So all you're going to do is take step 2 and set it equal to step 3, and you're going to solve for x. Okay? So an example of that would be up here. So find the value of C guaranteed by the mean value theorem for the function y equals cube root of x on the interval 0 to 8. Okay, so cube root of x, we know that that's continuous, so I always kind of make a comment on the continuity. So continuous, and I'm going to say yes. And so then I'm going to take the derivative. So the derivative of that, well, it might make it a little easier if you kind of say, well, the cube root of something, remember that's just a rational, so write it as power over root. So that's the same thing as this. So now that's easy to take the derivative of. It's 1/3 x, and then when you subtract 1 from the exponent, you get negative 2/3. Okay, well, I'm going to rewrite that. Remember, a negative exponent means that you can be written in the denominator. So power over root, so that's going to be the cube root of x squared. Okay, so I have that derivative. So I checked for continuity, I took the derivative. Now I need to use that average rate of change formula. So I need to say f of 8 minus f of 0 all over 8 minus 0. So to get these, I'm just going to go and plug in. Okay, so when you go to plug in there, when you plug in 8, okay, the cube root of 8 is 2, so I get a 2 there, minus, what do I get when I plug in 0? Well, when I plug in 0, the cube root of 0 is 0, so it's minus 0, all over 8 minus 0 is 8, so then I get 2 over 8, which is 1/4. So what the mean value theorem says is that somewhere in this interval, 0 to 8, that the derivative equals the average rate of change. And we want to know at what x value does that occur. So what we're going to do is we're going to take this and we're going to set it equal to that. So you can just say 1/3 cube root of x squared equals 1/4. And then you've got fractions with an equal sign between them, so you're going to go ahead and cross multiply. So you get 4 equals 3 cube root of x squared. And then you can solve for x there, probably divide both sides by 3. So then you get 4 over 3 equals the cube root of x squared. Some of you may choose to rewrite this in a rational exponent and then raise both sides to that form. I would probably just cube both sides first. So I would say I'm going to take this whole thing and cube it and say that that's going to equal x squared. Okay, and if I'm getting adventurous, I can go ahead and say, well, that's 4 cubed over 3 cubed, so that's 64 over 27 equals x squared, and then I could take the square root of both of those, and the square root of 64 is 8. The square root of that, ugh, that's yucky. I'm just going to leave it as square root of 27. So, and again, why did I not take the negative square root? It's going to be outside my interval there. but I have a value for x there that's guaranteed by the mean value theorem. So again, for that mean value theorem, your goal is to make sure that it's continuous. You're going to take a derivative. Then you're going to find the slope using that average rate of change formula, and you're going to set the derivative equal to that and solve for x. And that's all there is about, that's all there is to it, to the mean value theorem. All right, have a great day. See you soon. Okay, this is the homework for the absolute extrema and the mean value theorem. I didn't realize that it wasn't recording, so I'm just going to kind of walk through these two, and then I will actually be working the rest of the problems. So for the critical numbers of the function, and it says you do not need to find the extrema. So we're just finding the critical numbers. So basically all we're going to do is, from the notes, we're doing that step 1 and step 2, but we don't need to go back and plug them in because they're just asking us for the critical values. So remember, the critical numbers can also be called critical values. And in this case, basically it means you take the derivative of the function. So I took the derivative, used the power rule. Then you take that derivative, set it equal to 0. So from there I factored out an 3x. And then you set each piece equal to 0. Zero product property says anytime you have two things that are multiplied together that equal 0, if either one of them is 0, then you solve. So that equals 0, set that equal to 0, and I get 2. Very similarly with number 2, I took the derivative, and then I set the derivative equal to 0. This time I factored out a 4x. That left me with this x squared minus 4. That can be factored additionally into x plus 2x minus 2. That's the difference of two squares. And so then I have 0 and positive or negative 2 as the critical values this time. All right, and we will then go on to number 3. Okay, so in number 3 it says find the extrema of the function on the given interval. So the first thing we want to do is check its continuity. Okay, so we want to make a statement of saying that it is continuous, if so. So in this one, this is a polynomial. We're not dividing by a variable anywhere. We're not taking the square root of anything negative, right? So this is going to be continuous. So I would say something to the effect of step 1, is it continuous? And then I would say yes. Okay. And next, I want to take the derivative and then set the derivative equal to 0. So here it's called h, so we'll say h prime. Oops, so this is like step 2. H prime of x, that's going to be negative 2x. And then I just set negative 2x equal to 0. That's not going to be, that will exist everywhere, so I don't need to worry about that. I just need to set it equal to 0. And so when I set that equal to 0, I just get x equals 0. And so that would be my critical value. So 0 is the critical value or the critical number. Okay. Now what we need to do is we need to go back to the original, okay, and we plug in the endpoints and the critical value. So you need to plug in this 0 and negative 3 and 1 into the original. We had talked about using your calculator to make that quick. This one, the math isn't too bad, so I'll just kind of do it by hand. I would expect you to be able to do this without a calculator. But if you were just doing it to make it quicker, then that's fine too. So let's see, that squared would be 9, so it would be 5 minus 9. So over here I would get a negative 4. And then I always plug in my endpoints first just so that I don't forget them, but it doesn't really matter. So let's see, 1 squared is 1, so 5 minus 1, that's going to give me a positive, that'll give me a positive 4 there. And then I plug in 0, that was my critical value, so this minus 0 squared is still 0, right? But it'll be 5 minus 0 is 5. So then the important part is kind of looking at these y values and concluding which one is the maximum, which one is the minimum. So you'll see sometimes people put stars or, something like that. Here I feel like the maximum is going to be 5 and the minimum is going to be negative 4. So that's what you would write in your conclusion statement. You would say that there is an absolute minimum at, so the minimum point, this is the lowest y value, so the point would be negative 3, negative 4. and then the absolute maximum. The highest y value is 5, so the absolute maximum is at 0, 5, if you were writing it at the point. If you just wanted to say the maximum is 5 and the minimum is -3, that would probably also be accepted unless, of course, it was in the form of a multiple choice. Okay, so just make sure. They might also say, you know, at what point does the extreme occur? So just make sure you're answering the question. Okay, if they just want the max or min, that's the y value. But if they're asking you for the point, then you can think of that as the, you know, x and the y put together. Okay, up next in this number 4, again, the first step I want to do is make a conclusion about its continuity. So I say step 1, is it continuous? Is it continuous? And I say yes. Okay. And then I'm going to take the derivative. So step 2 is going to be to take the derivative. So here it's an f, so I'll say f prime of x is 3 times 2 is 6. Subtract 1 from the exponent, minus, and then I have 6 there. So then I'm supposed to take that derivative and set it equal to 0. So I'm going to take this and set it equal to 0. I'm going to factor out a 6 first. Not that it really matters, but equals 0. Okay. So then from here I'm going to factor this again. And again, you could have just solved it either way. You'll still end up with the same thing. You'll get x equals plus and minus 1. So I have two critical values there, positive 1 and negative 1. And then I'm going to go ahead for the step 3 and plug in positive 1, negative 1, and 0 and 3. And when I plug them in, you have to plug them into the original, because remember, we're trying to get a point. So whenever you're trying to get a point, you're going back to that original. And again, the order doesn't matter. I always kind of plug in my endpoints first so that I don't forget them. In fact, I think it's almost a good habit to kind of write them out like this first, and then solve them. That way you don't forget any. So I kind of write out all the things I'm evaluating. And again, I know that I'm plugging into the original because notice here it says f of 0. It doesn't say f prime of 0. So that f of 0 indicates that I'm plugging in to the original. So when I plug in to the original, let's see, if I plug in a 0, I'm going to get, oh, that's not really exciting, 0 minus 0, right? So that's going to be 0. When I plug in a 3, let's see, that'll be 3 cubed 27 times 2, so that'll be a 54. And then minus 18, because 3 times 6, negative 6 will be that. So that'll give me a 36. And when I try to plug in a negative 1, let's see, negative 1 cubed will be negative, so that'll be a negative 2. And negative times a negative will be a positive 6. So that's going to give me a positive 4 there. And similarly, this time when I plug in a 1, that'll be 2 minus 6 this time, though. And, oh, wait a second, that'll be a positive 2 there. Sorry. And minus 6, that'll give me a negative 4. Okay, so then I kind of look at these, and I say, okay, what's the lowest, and what is the highest? Those are going to be my absolute extrema, those also known as the maximum and minimum. So I can conclude that I have an absolute max over this interval, and an absolute min over this interval. So the minimum was that negative 4, right? So we've got 1, negative 4. And the absolute maximum, the largest, was that 36, so the point would be 336 then. Okay. All right, we'll kind of scooch that down maybe a little bit. All right, I might rewrite this original here. I would probably, as soon as I see that square root, I automatically try to rewrite it with a rational exponent so that I can take a derivative. Okay? And again, don't forget, we're still kind of concluding in the, you know, your step 1 should still be to say something about the continuity. You need to say something that it is continuous. Okay, so you can say continuous, yep. And step 2 then is to take the derivative. So g prime of x, so that's going to be 1/3 x raised to the, now if I subtract 1 from there, that gives me negative 2/3, okay? And I know for some of you, you're like, oh, that's your safe stop. I agree, that is the safe stop, but since we are trying to figure out where that's 0 or where it does not exist, right, we will need to kind of rewrite that so that we can see it. So I would say that that is also equivalent. Remember, it's power over root, so it's going to be the cube root of x squared, but it's a negative, so it's going to be in the denominator. So it's 1 over 3. This 3 is that. And then it's power over root, so it's then going to be the cube root of x squared. So that would be where that is mathematically equivalent. Okay? Okay, so this is the part where we normally set the derivative equal to 0. But in this case, we're going to also have to examine that other case of where the derivative does not exist. So to kind of demonstrate this, I kind of put it in my calculator just so you could see. Okay, so all I did was hit y equals, and then I just typed it into there, 1 over the cube root of x squared. Okay, now when I graph that, what you'll notice is, I wish it would have actually graphed it, but when it graphed it, it kind of went up like this, and then it like stopped, it jumped over, and then it kind of came back down here. So if I want to kind of see what's going on right at 0, I can look at the table. If you'll notice, at 0, there was an error on the table. Okay, so at 0, there was an error because, you know, we're not allowed to divide by 0. So it's not so much where the derivative equals 0. In this case, it's where the derivative is, where the derivative does not exist. So we are going to say that the derivative, okay, does not exist at what value? Well, that was at x equals 0. Okay. So where does it not exist? It does not exist when you divide by a 0. Again, we kind of talked about fractions, and you're not allowed to divide by 0. So the derivative does not exist when 1 over 3 cube root of x squared, when that equals 0, that's a problem. And to kind of do that, if you wanted, you could put that over 1, and you could cross multiply, and then solve for x there. Either way, you'd get when x is 0, that basically that is what gives you some bad news. I'm sorry, I kind of said it's where this equals 0, so I shouldn't have done 1 over this. Okay, it's just where this equals 0, so then you divide both sides by 3, and then you could square both sides and then, you know, take the cube, or cube both sides and then take the square. Either way, though, it's going to be 0. So again, when the derivative did not exist, when the denominator is 0, it goes there. So I accidentally carried that 1 over, but I shouldn't have. Sorry about that. Okay, so that is our critical value. So I'm not done yet, though, because now I need to go and plug in not only the endpoints, but also now this 0 into the original. So if you go and you plug in -8, that'd be what? The cube root of -8. You can take the cube root of a negative, you just can't take the square root. That gives you -2. Then, again, I usually do my endpoints first, just so that I don't forget about them. And the cube root of 8 is +2. And then I also take 0, plug it in there, and the cube root of 0 is 0. So then you could conclude that there is your absolute minimum. Okay, the minimum there is -2. So it would be at -8, -2. And your absolute max, the biggest number there is this +2. So in this case, the endpoints actually gave me the max, the absolute max and the absolute min. That isn't always the case, but it just so happened to be this time.